La alhamdulillah, salatu wassalam ala rasulillah. We give thanks to Almighty Allah, our Creator, our Fashioner, the Cherisher, the Sustainer of the universe. So we ask Allah to bless Prophet Muhammad sallallahu alaihi wasallam, his household, his companions, and the generality of Muslim Ummah to the day of accountability. Amin. This is lesson 2 lecture on the topic we started on water solution and solubility from the stable of CTY Model College, Ibadan, Nigeria. So, as presented by Master Ojekunle Ridwan Babatunde and Master Abdul Latif Mansour. So, as we have discussed before from the previous aspects of this work that we started with solution, we have defined solution as a mixture of a uniform, as a uniform or homogeneous mixture of two or more substances. We emphasize that the solute is a dissolved substance, which may be a solid, liquid, or a gas. And a solvent is a substance, usually a liquid, although it may be a solid or a gas, which dissolves a solute. So, and we also emphasize the types of solution. We also mentioned the types of colloids. Yes, we differentiated between true solution and a false solution. So we emphasize how Tyndall effect is arrived at. So today, inshallah, we want to look at the term or the concept we call solubility. How do we define solubility? Solubility is a means of comparing the extent to which different solutes can dissolve in a particular solvent at a definite temperature, at a particular temperature. Now, besides, we have what we call saturated and unsaturated solutions. When do we say a solution is saturated? A saturated solution of a solute at a particular temperature is one which contains as much solute as it can dissolve at that temperature in the presence of undissolved solute particles. The composition of a saturated solution is not affected by the presence of excess solute particles. On the other hand, an unsaturated solution, as the name suggests, it is not saturated. It can continue to dissolve more solute if added until the solution becomes saturated. The concentration of a saturated solution varies with three things: the solute, the solvent, and with the temperature. Now, in a saturated solution, the dissolved solute and the undissolved solute, the dissolved solute are there, and there are some undissolved solute there. They are in a state of equilibrium at a particular temperature, at a choosing temperature. They are in a state of equilibrium, meaning that any change that happens to the temperature of that particular saturated solution at that point in time will disturb this equilibrium, and the system must alter to counter the change. Now, it should be noted that since the solution of many substances is accompanied by heat absorption, so an increase in temperature will result in a corresponding increase in the solubility of these substances. On the other hand, when a saturated solution is cooled, excess solute would be made to crystallize out, to form crystals. Now, generally speaking, solubility decreases with a decrease in temperature, and it increases with increase in temperature, especially for most solid substances. Moving forward, we have what we call a supersaturated solution. What does it mean? It is the one which contains more of the solute than it can normally hold at that temperature. It contains more solute than what it can normally hold at that particular temperature. So such a solution is called what we call a supersaturated solution. Should be noted that a supersaturated solution, they are unstable. They are not as stable as a saturated solution. And the excess solute will separate out if the solution is disturbed slightly, touching it by shaking, or if a tiny crystal of the solute or even a dust particle is dropped into it. So even scratches inside the container can serve as centers of crystallization for the excess solute. We form crystal immediately if it is disturbed. Now, we should know that we can determine solubility of substances. That will now take us to what we call determination of solubility. The solubility of a solute in a solvent at a particular temperature, it is the maximum amount of the solute in moles or in grams that saturates 1 dm cube, that is 1000 centimeter cube of the solvent at that temperature. If you want to determine the solubility, two basic steps, two important stages are involved. First and foremost, stage 1, you prepare a saturated solution of the given solute at the specified temperature. You choose a temperature, be it at room temperature or at a higher temperature than that. So, preparing a saturated solution of the given solute at the specified temperature is the first step. Second step, taking a known mass of the saturated solution and heating it to dryness so that the exact mass of the solvent and the solute in the saturated solution at that temperature can be calculated. Having known this, we can plot what we call solubility graphs or curves for different substances, having known its solubilities at different temperatures, or having known their solubilities at different temperatures. If the solubility of a solute in a given solvent are plotted against their respective temperatures, a solubility graph or curve showing the effect of temperature on the solubility of the substance will be obtained. For comparing the solubility of different solutes in a given solvent, several curves can be plotted on the same axis, as we will see in the curves that we have underneath. The solubility of most solid solids increases with a rise in temperature, while the solubility of most common gases decreases with a rise in temperature. Should be noted that hydrogen chloride gas is an exemption from the gases that would have their solubility decreasing with a rise in temperature. Hydrogen chloride gas is generally what's most commonly soluble. It's kind of a gas that is properly or well soluble in water. Also, the solubility of a gas is directly proportional to the pressure of the gas. Looking at this graph, for solids, we have different substances here, different solids, and their solubilities at different temperatures are plotted. I will plot these different curves together here for proper comparison. We have NaNO3, we have CaCl2, we have PbNO3, NaCl, KCl, KCl3, K2Cl2O7, Ce2, SO4, and the likes. Now, there are a lot of conclusions that we can draw from this graph. Number one, from this graph, as we can see, solubility of potassium triisochlorate 5 and potassium triazonitrate 5 increase very rapidly with increase in temperature. That is KCl and KClO3. Yes, increase rapidly, very rapidly with increase in temperature. Also, solubility of sodium chloride and calcium hydroxide are independent of temperature. Look at NaCl here, blue, the blue curve there, and so calcium hydroxide. Yes, they are what? They are independent of what? Of temperature. Apart from that, sodium tetraoxide 6 shows a solubility curve with a sharp peak at 36 degrees Celsius. That's Na2CO3. So now we have the solubilities of different compounds. Like look at lead nitrate. Lead nitrate here also increases steadily with an increase in temperature. We have K2Cl2O7, it also increases steadily with an increase in temperature. So we have KCl, that is the potassium chloride increases at a constant rate with the rise in temperature, and so on and so forth for solids, solutes. Now, for gases, as we have established, increase in temperature will bring about decrease in solubility for most gases. As this graph here depicts. Now, where do we apply these solubility curves? What are their importance? The curves enable pharmacists to determine the amount of solid drugs to be dissolved in a given quantity of solvent to give a prescribed drug mixture. The curves enable researchers and chemists to determine the most suitable solvent for extraction of essential chemicals. Solubility curves help in separation or purification of a given mixture of solids by fractional crystallization. These are few of the applications of a solubility curves. Now, these are some worked examples on how to determine the solubility of some substances having known their solubility at a particular temperature. Question number 1 here says if 12.2 gram of lead 2 triazonitrate 5 were dissolved in 21 gram of distilled water at 20 degrees Celsius, that's around the room temperature, calculate the solubility of the solute in mole per dm³. Now, solution. Molar mass of lead nitrate PbNO3 is equal to 331 gram. We have a reacting mass or given mass as 12.2. So the number of moles that one will give us is 0.037 moles. Should be noted that 1 gram is equivalent to 1 cm³ when we are talking about solubility or for most calculations in chemistry. Now, we are given 21 gram of distilled water, so it will be converted to cm³. If that 21 grams is converted, we are going to have 21 cm³ of water. That is meaning 21 cm³ of water dissolved 0.037 mole of lead nitrate. Now, if you now have 1000 cm³, what will it dissolve? So if 21 dissolves 0.037, 1000 will dissolve X. So making X the result of the formula, 1000 times 0.037 divided by 21. So that gives us 1.76 moles of lead nitrate. That is for example 1. Number 2, solubility of potassium triazonitrate 5 is exactly 1,800 gram per 1,000 gram of water at 80 degrees Celsius and 700 gram per 1,000 gram of water at 40 degrees Celsius. Calculate the mass of potassium triazonitrate 5 that will crystallize out of solution. If 155 gram of the saturated solution at 83 degrees Celsius is cooled to 40 degrees Celsius. Now, the solution to the question. Note that solvent plus solute is called solution. Masses involved at 80 degrees Celsius is 1,000 gram plus 1,008, giving us 2,800 gram. With the whole value of the solution, the volume of the solution, or the gram of the solution. Masses involved at 40 degrees Celsius, 1,000 plus 700, that is 1,700. If that solution is made to cool from 83 degrees Celsius to 40 degrees Celsius, So the solute that will be deposited will be 1100 gram. Meaning that if you have 2,800 gram of saturated solution, it's going to deposit 1100 gram of solute. From the question, if you now have 155 gram of the saturated solution at 80 degrees Celsius being cooled to 40 degrees Celsius, what will be the value of the what? Of the solute, that is potassium triazonitrate 5, that would crystallize out of the solution? A simple ratio. 2008 gives us 1100. 155 will give us an unknown value, let's say x or y. If you cross multiply, making y the subject of the formula, we're going to have 155 multiplied by 1100 divided by 2,800. So at the end of the day, we're going to have 60.89 gram of solute being crystallized out if 155 gram of the saturated solution is cooled from 83 degrees Celsius to 40 degrees Celsius. So I pray Allah subhanahu wa ta'ala grant us knowledge, wisdom and understanding of what we have said so far. May Allah bless our knowledge. I pray Allah subhanahu wa ta'ala bless our parents, bless our school, and put barakah in our knowledge, protect us. May Allah subhanahu wa ta'ala let us overcome this coronavirus that is disturbing the whole world. May Allah protect us from its evils and our families. So bi rahmatika ya arhamar rahimin. So I say assalamu alaikum wa rahmatullahi wa barakatuh.